Assalamu alaikum wa rahmatullah. Hello, grade 9 students. Welcome to our Eduverse Science Revision. This is Miss May Muhammad Al-Khayyam. Today, inshallah, we're going to revise and practice on some important notes and tips that will help you to get ready for your exam. Are you ready? Let's go. So we'll start our revision with Unit 1, Lesson 1, which is chemical reactions. And if you have any problem with oxidation reduction reaction, just wait for the story of Donald Duck and MacDuck that will help you to master this part. Stay tuned. What is a chemical reaction? A chemical reaction, it is the breaking of bonds in the reactant molecules and formation of new bonds in the molecules of the products. How many kinds of chemical reaction or types of chemical reaction do we have? We have 3 types of chemical reactions. First, the thermal decomposition reactions, which include the decomposition of some metal oxides or the decomposition of some metal hydroxides, also the decomposition of most metal carbonates and most metal sulfates, and finally, the decomposition of some metal nitrates. The second type of reactions, which will be the substitution reactions. This is the simple substitution reactions and the double substitution reactions. In simple substitution reaction, we'll learn about a metal substitutes the hydrogen of water, a metal substitutes the hydrogen of diluted acid, and a metal substitutes another metal in its salt solution. While in double substitution reactions, we'll learn about the double substitution that takes place between an acid and alkali, and the double substitution between an acid and a salt, and the double substitution between 2 salt solutions. And finally, the oxidation and reduction reactions, which include according to the traditional concept and according to modern or electronic concept. This is an overview for the whole types of reactions. This is a good way to help you study this part. You can do it here alone. Okay, so let's go. The thermal decomposition reactions, they are chemical reactions which involve the breaking up of the compounds with the effect of heat into its primary elements or simpler components than the original ones. So from its name, you can guess about the meaning. Thermal means heat, while decomposition means dissociation or breaking up. As you can see here, compound AB, okay, by heating, it will be decomposed or broken down into A alone plus B alone. Thermal decomposition reactions, as we just mentioned, it includes what? Decomposition of some metal oxides like 2-mercuric oxide, which is red in color, by heat will give us 2-mercury, which is silver, and oxygen gas. While the decomposition of some metal hydroxides, like the reaction of or the decomposition of copper hydroxide by heating will give us copper oxide and water. Pay attention, copper hydroxide is blue in color, and by heating it will give us the black copper oxide. Why do we have 2 of the atomic group hydroxide? This is because copper is divalent, while hydroxide group is monovalent. Please pay attention to the balance of any equation. Now, with the decomposition of most metal carbonates like copper carbonate, which is green in color, by heating will give us black copper oxide and carbon dioxide gas. And the decomposition of most metal sulfates, like the decomposition of copper sulfate, which is blue also, by heating will give us black copper oxide plus sulfur trioxide gas. And finally, the decomposition of some metal nitrates, like sodium nitrate, which is white in color, by heating will give us yellowish-white sodium nitrite plus oxygen gas. So this is nitrate and this is nitrite. You may ask me about, it is a little bit confusing to know the kind of gas that will evolve from the reaction. I can help you here with, if you have oxygen in the reactants, so oxygen gas, while hydroxide, it is composed of hydrogen and oxygen, so you can guess that, it will form water, while carbonate, carbon dioxide gas. How can we test for the evolve of these gases? Actually, I can test for the presence of oxygen gas by approaching a match to the test tube, which will, glow more. While for carbon dioxide, it turbines lime water. Now, with the airbags is one of the safety means in new cars, which will help us in car crash or sudden drop in the speed of the car. God bless all of us. So in this case, an electric spark will work on the substance, which is called sodium azide, and decompose it into sodium and nitrogen gas. Nitrogen gas will fill the bag just to keep you safe. Now, with the substitution reactions, from its name, you can guess that one element here, so substitution reactions occur where there is an active element replaces or substitutes another less active element in another compound. You may ask me, but how do I know that this is more active than another? This depends on the chemical activity series. So as you can see here, it is the arrangement of metals in a descending order according to the degree of their chemical activity. Yes, you have to memorize them in order. So don't forget, in a descending order, which means that this is the most active element or most active metal, and this is the least one. Potassium, sodium, barium, calcium, magnesium, aluminum, zinc, iron, tin, lead, all of them precede hydrogen in the chemical activity series, while copper, mercury, and silver, platinum, and gold, they come after the hydrogen. So they cannot replace hydrogen. Now, with the two types of the substitution reactions, the simple substitution reactions and the double substitution reactions, as you can see here from these two pictures, in simple substitution reactions, I can say that just one element will substitute another element in its compound, while here, double substitution takes place. Let's introduce the definition of each one of them. Simple substitution reactions, they are chemical reactions in which one of elements substitutes another less active element in a solution of one of its components. While in double substitution reaction, as we just mentioned, they are chemical reaction in which double substitution exchange occurs between the ions or radicals of two different compounds to give two other new compounds. Please pay attention to the double substitution reaction because we're going to take this definition in an important question. It happens between ions or radicals. Okay. Now, the substitution reactions, as we just mentioned, types of simple substitution reactions, we have a metal substitutes the hydrogen of water, and as we can see here, this is one of the famous reactions. We all know sodium plus water will give 2 sodium hydroxide plus hydrogen gas plus heat. Okay, how can we test for the hydrogen gas? It makes a pop sound with ignition. Pay attention, this is one of the exothermic reactions, and be careful with this reaction. And pay attention to one of the questions. It can come as sodium plus water gives what? Or a metal plus water will give metal hydroxide plus hydrogen plus heat. The other example is a metal substitutes the hydrogen of diluted acid. What is the most famous diluted acid do we know? The hydrochloric acid. So zinc plus 2 hydrochloric acid, which is diluted, will give zinc chloride plus hydrogen gas, while 2 aluminum plus 6 hydrochloric acid, which is diluted, also will give 2 aluminum chloride plus 3 hydrogen gas. Please pay attention to the balancing of each equation. While copper plus hydrochloric acid, no reaction. Why? Because copper comes after hydrogen in the chemical activity series, so it cannot replace it. Okay. Now, with a metal substitutes another metal in its salt solution, like magnesium plus copper sulfate, because magnesium here is more active than copper. It precedes the copper in the chemical activity series, so it will replace it, leaving copper PPT. So it will give magnesium sulfate plus copper, which is red. Here, copper sulfate is blue. The copper will be red. Types of double substitution reactions, reaction between an acid and an alkali, which is called neutralization reaction. This name is very important. Neutralization reaction includes the reaction between an acid and alkali to form or to give salt and water. The example for this is sodium hydroxide, which is in the alkali, and the hydrochloric acid. Sodium will take the chloride, while H will take the OH to form water. Now, here, the reaction between an acid and a salt. Acid and a salt, so we can guess about this acid also, which is hydrochloric acid plus sodium carbonate. Sodium carbonate plus 2 hydrochloric acid will give 2 sodium chloride plus water plus carbon dioxide. So if you're asked about what is the kind of gas that evolves In this reaction, it's carbon dioxide. Again, I have here carbonate. So you can guess about the kind of gas that will evolve. Now, reaction between two salt solutions. This is one of the most important reactions here. And it gives what? Yeah, precipitate. So you can have a question about these kinds of reaction between two salt solutions, like sodium chloride plus silver nitrate. Double substitution reaction will take place, and the sodium will take the nitrate, and the silver will take the chloride to form silver chloride white precipitate, which doesn't dissolve in water. Okay, let's go. Oxidation and reduction reactions. Here we come with these kinds of reactions. According to the traditional concept, which is based on giving and taking away oxygen or hydrogen, or according to the electronic concept, which is by losing or gaining electrons. Let's talk more about this kind of oxidation reduction reaction, the traditional concept. So if we have copper oxide, which is black, and we passed hydrogen gas on it, so the hydrogen will take the oxygen from the copper oxide, leaving copper, which is red. Okay, this is the oxidation reduction reaction. So if you're asked to write oxidation reduction reaction on the reaction itself, you have to write it in this way. Hydrogen, okay, plus copper oxide. Let me tell you something. Copper oxide is the rich guy. Why? Because it has oxygen with it. We'll consider oxygen as money. So copper oxide is the oxidizing agent. And the hydrogen is the poor guy because it doesn't have oxygen. When they react with each other, the hydrogen will take the oxygen from the copper oxide. And now this is the reducing agent. Why? Because it reduces the oxygen in copper oxide. But when copper oxide gives oxygen to the hydrogen, it will be left with no oxygen. So it is reduced. Reduction process happens to it. And the hydrogen, when it takes oxygen from copper oxide, it is oxidized. Is it a little bit confusing? Now I can help you with a tip here. The name of the agent is the opposite of the name of the process that takes place to it. Let's apply this. Copper oxide is the oxidizing agent, the rich guy. What will happen to it? It will be reduced. So this is the name of the process is the opposite of the name of the agent. While hydrogen is the reducing agent, it will be oxidized. Again, with this story, let's see it. MacDuck and Donald Duck. MacDuck is the rich guy. Let's see that he is the copper oxide. And he's rich because, has oxygen with it. While hydrogen here, the Donald Duck is the poor guy. Now, when copper oxide or Mr. MacDuck will give oxygen to Donald Duck, what will happen to this hydrogen? Yes, it will be oxidized. And it will have oxygen with it. While the copper oxide, after giving away the oxygen to hydrogen, it will be reduced. I hope that this story helped you to master this part. Now, oxidation and reduction reaction according to the electronic concept by losing and gaining electrons. As you can see here, a substance will lose electrons, which will be gained by another substance in this reaction. Okay, like what? The reaction between 2 sodium plus chlorine will give 2 sodium chloride. Please pay attention. To understand this part, your eyes on the reactants and products. Ask yourself, which parts have changed? So let's talk about sodium. Sodium is neutral here. To change to be sodium positive, a positive sodium ion, so it lost 1 electron. I will make you memorize just one of them, and you have to conclude the others. Just memorize that in oxidation reduction reactions according to electronic concept, oxidation is the losing of electrons or the loss of electrons. And as we know, the name of the agent is the opposite of the name of the process. So sodium will lose electrons. This is oxidation process. and it becomes a reducing agent. While chlorine to be chloride negative ion, so it will gain the lost electrons from the sodium, and this is reduction process. What is the name of chlorine here? It is oxidizing agent. Okay, just a note, any chemical process includes losing of electrons is known as an oxidation process. Let's check this part. I have copper, which will be changed into positive copper ion plus 2 electrons. Why this is oxidation? Again, your eyes on the reactants. This is a neutral one, and it will be changed into positive ion. To change into a positive ion, this means that it lost electrons. Losing electrons is written like this, okay, the oxidation process. So the 2 electrons are written on the resultants. Okay, here the fluoride ion will be changed into fluorine again. Fluoride ion is negative. To change to be neutral, so it has to lose this excess electron. Losing electrons again means oxidation. Also, the chemical process which includes gaining of electrons is known as a reduction process. Like what? Silver. Okay, here it is positive silver ion plus electron. So when we add an electron to the silver or the positive silver ion, it will be neutral. So this is reduction process. Pay attention, the electron is added in the reactants. While here, the bromine, which is neutral, to change it to bromide, this means that it has to accept or gain an electron. So it will be changed into bromide or negative bromide ion. Now, pay attention to the definitions of reducing agent and oxidizing agent according to traditional concepts and electronic concepts. If we're going to talk about the reducing agent according to the traditional concept, it is the substance which takes oxygen or gives hydrogen. And what happens to it? Oxidation process, which causes the increase in the oxygen percentage or decrease in the hydrogen percentage. While oxidizing agent gives oxygen or takes away hydrogen. And what happens to it? Reduction, which causes the decrease in the oxygen percentage or increase in the hydrogen percentage. According to electronic concept, the reducing agent or factor, it is the substance which loses an electron or more during a chemical reaction, while oxidizing agent, the substance which gains an electron or more. What will happen to the reducing agent? The opposite to it, oxidation process. It is oxidized, which includes the atom loses an electron or more, while reduction, the atom gains an electron or more. This is a way to master all of the chemical reactions here. You can take a screenshot for it, or even you can write it alone. Okay, let's go. Unit 1, Lesson 2, speed or rate of chemical reactions. If I asked you about some chemical reactions, you may describe them as very fast reactions because they take a very short time, like fireworks, or even the relatively slow reactions which take a short time, like the reaction between caustic soda, sodium hydroxide, and oil to form soap. And also the very slow reactions, you may think about the rusting of iron, which takes about a month. And finally, the 2 slow reactions, for sure, you're going to think about the formation of petroleum oil that takes place in millions of years or needs millions of years to take place. Now, the speed of chemical reaction, we all know I have some reactants that will react with each other to form products. So at 0 time, please pay attention to this. Here, the measuring unit of concentration of substance is mole per liter. You're going to take this later, inshallah, in secondary stage. But let's talk about this now. What about 0 time? So to answer these questions, you have to look at 0 time. At 0 time, as you can see here, okay, or at the beginning of the reaction, the concentration of the reactants X, which is here illustrated with the blue curve, is the largest, is 100%. While the concentration of the products here, which is illustrated by the red curve, is 0%. But by passing time, the concentration of reactants decreases just to be changed into products, and the concentration of products increases. At the end of the reaction, for sure, the concentration of the reactants will be 0, while the concentration of products will reach to its maximum or the largest concentration, which is 100%. So now we can define the speed of chemical reaction. It is the change in the concentration of reactants and products or resultants at a unit time. The speed of decomposition or dissociation of nitrogen pentoxide. Nitrogen pentoxide, penta means 5. Pentoxide means I have 5 oxygen. So it is written like this. I need 2 molecules of nitrogen pentoxide to give 4 nitrogen dioxide plus oxygen gas. If we're going to illustrate this as a graph, so please, again, your eyes on 0 time. At 0 time, you can tell me about the reactants and products. How to look at 0 time and tell me which curve is the largest concentration. You will say the green one. So the green one is the nitrogen pentoxide, while both of the 2 red curves are the nitrogen dioxide and oxygen gas. But which one of them is the oxygen gas and which one is the nitrogen dioxide? Please look at the concentration of oxygen. It is 0.08 mole per liter, while the concentration of nitrogen pentoxide, it is 0.16. You can say that this number is double this number. And the concentration of nitrogen dioxide is 0.32, which also double 0.16 or 4 times 0.8. So as you can tell me here, you can tell about this from the balancing of the equation. Here I have 2 of nitrogen pentoxide, which is double the oxygen, and 4 nitrogen dioxide, which is double nitrogen pentoxide or 4 times the oxygen. You can tell me about this from the number beside the molecules. Let's check this here. The opposite graph represents the breaking of the compound X as in the following equation. 2x gives 2y plus z. Replace the numbers with x, y, and z. Again, how can you answer this question? 0 time. Look at 0 time. Which one is the largest concentration? Is it the green, the red, or the blue? The blue one. So the blue one represents the reactants, while the green and red one. Now, is it confusing? No. Let's see. The concentration of 3 is the same concentration of 1, 2, and 2. So for sure, 3 represents the Y. While Z represents the Z. Okay. Another one here, the opposite graph represents the relation for certain reaction. Write the symbolic equation for this reaction. Here, as you can see here, again at 0 time, I have 2 reactants, A and B, but the concentration of A is double the concentration of B, while the concentration of C is the same concentration of A, and C, pay attention, is the products. So we can say that if I have 1 of B and 2 of A, therefore I have 2 of C also. Let's write it with each other. It will be 2A plus B gives 2C. Now, measuring the speed of a chemical reaction. The speed of a reaction is measured by the rate of disappearance of one of the reactants or appearance of one of the resultants. Let's see this reaction. Rate of reaction of sodium hydroxide solution with copper sulfate solution. If I have sodium hydroxide, 2 sodium hydroxide plus copper sulfate, which is blue in color, this is one of the double substitution reactions. The sodium will take the sulfate, gives colorless sodium sulfate plus copper hydroxide, which is also blue. Okay, so you will tell me, how can I measure the speed of this chemical reaction? It is by the disappearance rate of the blue color of copper sulfate solution. As you can see here, this is the blue color of copper sulfate, and the formation rate of the blue color of precipitate of copper hydroxide. Now, factors affecting the speed of chemical reactions. The nature of reactants or the concentration of reactants, the temperature of reaction, and catalysts. So we have 4 factors. Under the nature of reactants, I have another 2 factors, the kind of bonding in the reactants and the surface area of reactants exposed to the reaction. Kind of bonding, we all know we have ionic compounds or covalent compounds, or ionic bonds or covalent bonds. Ionic compounds react faster than covalent compounds. Why? Because ionic compounds can be ionized when they are dissolved in water, while the covalent compounds, the reaction takes place between molecules that cannot be ionized when they are dissolved in water. The surface area here, also we're going to tell about the kind of bonding in the reactants, like sodium chloride plus silver nitrate. Please pay attention to this. If you remember, I told you about the definition of double substitution reaction. This is one of the double substitution reactions, and I said double substitution reaction takes place between radicals or ions. So any double substitution reaction can be considered as a fast reaction because it takes place between ions. While the surface area of reactants exposed to the reaction here, it will be what? If I have substance A that would like to react with substance B, but as you can see here, it is in a cube form. So substance A will react only with the outer surface of substance B. But what if I'm going to grind or break down substance B? So substance A will react with the outer and inner part of substance B. So increasing the surface area of reactants to expose to the reaction increases their speed of reaction. Why? Due to the increase in the number of reactant molecules exposed to the reaction. Now, the concentration here, also we're going to talk about it, but as we're going to see here an example, iron plus 2 hydrochloric acid gives iron, is it iron? No, it is ferrous chloride. Pay attention, why ferrous? Because it is positive 2 plus hydrogen gas. Oh, how is this related to the surface area? Okay, if I used iron cube or iron fillings. So iron fillings will react faster than using iron cube. Now with the concentration of reactants, for sure, if we're going to increase the concentration of any reactant, this will increase the number of probable collisions between the reactants. So increase the rate or speed of chemical reaction, as in magnesium plus 2 hydrochloric acid gives magnesium chloride plus hydrogen gas. You will ask me, where is the increase in the concentration? Actually, if we're going to use dilute hydrochloric acid or concentrated hydrochloric acid. So this is a way to increase the concentration of reactants by increasing the hydrochloric acid concentration. Therefore, the speed of chemical reaction will increase. Temperature of reaction, of course, when we heat the container here, the also number of probable collisions between the reactants will increase, therefore increasing the speed of chemical reaction. As when we're going to dissolve an effervescent tablet here in cold water and in hot water. Which one do you think is faster than the other? It's beaker A. Why? As you can see, a lot of effervescence here happens. A catalyst. A catalyst is a chemical substance. Let's see first. I can describe it as, Super Mario, or we can say super catalyst. It shows a shorter way to the reactants to form the products. But let's define the catalyst. It is a chemical substance which changes the rate of chemical reaction without changing or being used up. Please pay attention. Any catalyst will not be used up in the reaction, or even its mass, the mass will be constant. I have 5 properties for the catalyst. Be sure to revise them. Like the decomposition of hydrogen peroxide, hydrogen pair means 2. So I have 2 molecules of hydrogen peroxide. It is like water, but it has excess oxygen. So it's H2O2. By a catalyst, which is manganese dioxide. Please pay attention also, manganese dioxide, because it's a catalyst, it's written on the arrow. If you're going to write it here beside the reactant, it will be considered as a reactant also, but it is written here on the arrow. It will give 2 molecules of water plus oxygen gas. I have another way to increase the decomposition rate of hydrogen peroxide by using an enzyme. But what are enzymes? Enzymes are biological catalysts, which are produced by some body parts of the living organisms, or the body of living organisms. Like what? We're going to talk about the oxidase enzyme in the potato, which has the same effect on what? Hydrogen peroxide to increase its decomposition rate. Okay, let's go. This is a way also to collect all of the reactions that we talked about in this lesson. Just be careful to revise from your book. I have here also positive catalytic reactions, negative catalytic reactions, and we talked about catalytic converter. Catalytic converter, it is a metallic can that exists in most modern cars to treat the harmful gases emitted from the engine. Okay, let's go. So are you ready to practice? I know that you can do it. Let's go. When calcium carbonate is heated, what are obtained? Choose the correct answer. So calcium carbonate, like, copper carbonate. I have carbon dioxide. All of them have carbon dioxide. But it will give calcium oxide and carbon dioxide. Aluminum practically lates in the reaction with hydrochloric acid due to the presence of what layer? This is one of the important questions. Due to the presence of aluminum oxide, Al2O3. Double substitution reactions between two salt solutions are accompanied by formation of, okay, pay attention to this, to a precipitate, like the reaction between sodium chloride plus silver nitrate. It will give silver chloride precipitate. Active metals react with water as they substitute the hydrogen of water, forming, I told you about this, metal hydroxide. Like the sodium will take the hydroxide from the water and leaves hydrogen gas. When magnesium replaces copper in its salt solution, a what precipitate is formed? Okay, magnesium plus copper, but copper what in its salt solution? Like copper sulfate. So it will give magnesium sulfate plus copper, which is red in color. During the reaction between hydrogen and black copper oxide, what process occurs to copper oxide? Copper oxide is the oxidizing agent, the rich guy, which will give oxygen to hydrogen. So what will happen to it after giving away the oxygen? It will be reduced. So reduction process takes place. When nitrogen pentoxide gas is decomposed, what gas is evolved? I have here a lot of oxygens. For sure, it will give us oxygen. In the reaction here, the positive, chromium plus 3 zinc will give, the chromium plus positive iron zinc. So the chromium here, please pay attention. I have to ask myself, what happened to this element? Here, is it neutral or ionized? It is ionized, it is positive, and it changed into the products to be, neutral. So to be neutral, it should gain electrons. It should gain electrons. Gaining electrons, so let me write it here. So it gained electrons. Gaining electrons means what? Reduction process. So this one is the oxidizing agent. Now let's see. So is the oxidizing agent? Yes, it is the oxidizing agent. It is not the reducing agent. Is it oxidized? No, it's not oxidized. It is reduced. Is it reduced? Yes. Does it oxidize zinc? Yes, because it's an oxidizing agent, so it oxidizes zinc. So I have A, D, and E. So the answer here will be, C. The correct answer is A, D, and E. On adding copper turning to diluted hydrochloric acid, what will happen? Pay attention. Copper with hydrochloric acid. No reaction occurs because copper comes after the hydrogen in the chemical activity series. At the ending of any chemical reaction, the concentration of reactants at the end will be, 0 for sure. The change number what represents reduction process. Reduction means gaining electrons. Here, let's, see that. Actually, it lost electrons to be positive, while here it was negative and it became neutral. So it lost the negative. Here, it was negative also and became neutral. So also it lost electrons. The only one that gained electrons here is positive copper ion that will turn into neutral atom here, copper. Actually, as you can see here, to neutralize the positive here, or just not neutralize, just to change from positive to neutral. So it will be gaining electrons. So this is the answer. In the reaction hydrogen plus chlorine, which gives 2 hydrochloric acid, which of these elements describe the rate of this chemical reaction? Actually, the reactants will decrease by time, and the products will increase by time. So here, the concentration of hydrochloric acid increases. Why? Because this is the products. The reaction between silver nitrate solution and sodium chloride solution is, for sure, this is one of the fast reaction because it happens between radicals or ions. The rate of breaking up of hydrogen peroxide increases by the addition of manganese dioxide. Don't be confused between manganese dioxide and manganese. Maybe he is going to write it as magnesium dioxide. So it is manganese dioxide. Put true or false and correct what is wrong. Chlorine atom changes into chloride ion when it loses an electron. So chlorine, to be chloride, it is negative. So it gains electrons, not loses an electron. So this is wrong. Some metal nitrates decompose by heat into metal nitrate and hydrogen gas evolves. This is also wrong. Why? Because metal nitrates decompose by heat into metal nitrite and oxygen gas evolves. Oxidation and reduction are separated process? No, this is one of the important questions also. Oxidation and reduction are concurrent processes because the number of gained electrons is the same number of lost electrons. The speed of the reaction of sodium hydroxide solution with copper sulfate solution is measured practically by the rate of appearance of the blue color of copper sulfate. This is wrong. It is by the rate of disappearance of the blue color of copper sulfate because this is one of the reactants. Or we can say by the rate of appearance of the blue precipitate of, yes, copper hydroxide because this is the products. The catalyst is a substance that increases the speed of chemical reaction because it decreases the energy needed for the reaction. Yes, this is one of the properties of the catalysts. Write the scientific term. The metallic can exist in most modern cars. Okay, this is for sure catalytic converter. The enzyme which is found in sweet potato, this is the oxidase enzyme. It is the substance which loses an electron or more during the chemical reaction. Okay, for sure, this is the reducing agent. This is a very important and different example here or question. Give reason. Oxidation or reduction processes didn't happen in the double substitution reaction. Okay, we all know that oxidation and reduction cares about or what it deals with, losing and gaining electrons. What about double substitution reactions? Like what? Double substitution reaction, like the reaction between, as we all know, let's write it, the sodium chloride plus silver nitrate. It will give us what? Sodium nitrate plus silver chloride. If we're going to see here, it is positive, here it is negative, positive, and negative. Also positive, negative, positive, negative. If you look at all of the reactants and products here, all of them are ionized. None of them have changed. The sodium is the same, the silver is the same, also the nitrate and the chloride. So in double substitution reactions here, I don't have any gaining or losing electrons. So let's rephrase the answer now. This is because what? The double substitution reactions occur between ions without losing or gaining electrons. Which of the following sequence express the speed of chemical reactions? As you can see here, I have 5 grams of iron fillings, 5 grams of iron cube, 5 grams of zinc cube. Zinc is more active than iron, so it is the first one to react. While here, because I have fillings, by increasing the surface area, so it is more active or it will react faster than B. So the correct sequence will be C, more than A, more than B. Choose the odd word. Products volume, reactants concentration, temperature, and catalysts. For sure, products volume. All of the others are factors affecting rate of chemical reaction. Potassium, gold, sodium, calcium. Think about it. It is gold. Why? Because it comes after hydrogen in the chemical activity series, while the others come before them. Type of bonding in reactants, temperature of reaction, surface area of reactants exposed to the reaction. For sure, it is the temperature of reaction because the others are, the nature of reactants. Let's see this important example also. Here I have 4 graphs. I have to relate them to the correct equations. Number 1, Okay, I can help you with the tip here. I have a straight line. This straight line means that the concentration of this substance doesn't change from the beginning till the end of the reaction. So for sure, this is the catalyst. Where is the reaction here, which is considered with the catalyst? This one. So number one, or graph number one, goes to the second reaction. But what about this reaction here? Okay, I have here nitrogen plus 3 hydrogen. I have 2 reactants. I have 1 product. Let's search for 2 reactants and 1 product. 2 reactants. Okay, for sure, this is 4. Okay, 2 reactants, because at 0 time, I have 2 reactants. And we answered this part. Now, with nitrogen pentoxide gives nitrogen dioxide and oxygen. This is so easy because of the concentration of each. I have is this one or this one? No, this product is half this reactant, and this product is double this reactant. So it is number 2. And finally, this is for sure number 3. Show by the chemical equations only how can you obtain copper from copper sulfate in 2 different methods. Okay, so if I have copper sulfate, how can I get copper? Just by heating, it will give us copper oxide plus sulfur trioxide gas. I still didn't get our copper. Copper oxide here, okay, I can take it plus hydrogen, okay, so it will give us, the copper plus water. This is a way. Another way, I have what? Copper sulfate plus magnesium. Magnesium will take the sulfate, leaving copper alone. So let's see that. This is the first way, and this is the second way. Okay. So let's go. Welcome back with Unit 2, Lesson 1, which is physical properties of the electric current. Let's see. The electric circuit. We all know that we have electricity and we use it every day and so on. But what about this electric circuit? It is composed of an electric key or switch, an electric lamp, a connecting wire, and a dry cell. Okay, let's go. Have you ever thought where the electric current is generated? Let's see that. Here, we all know that any atom has a nucleus, which has what? Protons, which are positively charged, and neutrons, which are neutral. And around the nucleus, revolving the electrons. The attraction force between the protons in the nucleus and the electrons in the outermost energy levels, okay, keep the electrons in their orbit. But actually, when the attraction force between the protons in the nucleus and the electrons in the outermost energy level is weak or vanished, electrons will leave the atom and become free to move. Therefore, what is an electric current? The word current means flow, the movement. So when I say water current, this means the movement or flow of water, like in rivers. While here, when we're talking about electric current, it is the flow of negative charged electrons through a conducting material, which is the metal wire. This is a cross-section, okay? The flow of free electrons through a cross-section of a conductor. Now, let's go with some physical properties of the electric current. I have 3 physical properties. The first one, the current intensity. The second one, the potential difference. And the third one, the resistance. Current intensity. We all know now current means flow. But what about intensity? Intensity means strength. Okay, so the strength of the electrons that flow in a cross-section of a conductor. We can describe that by, it is the quantity of electricity in coulomb, or the electric charge flowing through a cross-section of a conductor in 1 second. So if I'm going to get a part of or a section of a wire, and I have to count how many electrons passing through this wire in 1 second. Please pay attention. Time here is given in seconds. The relation here can be calculated by this magic triangle, which is current intensity I equals the quantity of a charge or electric charge divided by the time in seconds. The measuring unit of current intensity is ampere, while the measuring unit of the quantity of charge is coulomb, and the measuring unit of the time is seconds. Therefore, here, this is also the ammeter. Ammeter here is an apparatus used to measure the current intensity, and pay attention, it should be connected in series. What is the meaning of in series? So it is one of the components of the circuit itself. And the positive pole of the ammeter should be connected to the positive pole of the dry cell or the battery, and the negative pole should be connected to the negative pole. Okay, the potential difference. First of all, we have to define the electric potential of a conductor. What is an electric potential of a conductor? If I have two conductors, one of them is with it has high electrons than the other. So the electrons will flow from higher to lower. Let's now define the electric potential of conductor. It is the state of an electric conductor. What is the meaning of state? Condition. So what is the condition of this? Is it having more electrons or less than the other? So I have to differentiate between them or to compare between them. So it is the state of an electric conductor that shows the transfer of electricity from or to it when it is connected to another conductor. Why when it is connected to another conductor? Just to tell if it has more or less. From this point, we have to know the potential difference across two terminals of conductor. For sure, to transfer some electrons from one part to another or across two terminals of conductor, I need work. So it is the work done to transfer a quantity of electric charge of 1 coulomb between the two ends of this conductor. And it can be calculated by potential difference, which is V equals the work done over the quantity of a charge. The measuring unit of potential difference is volt, measuring unit of work done is joule, and the measuring unit of the quantity of charge, for sure, coulomb. Here is the voltmeter. Also, it is an apparatus to measure what? To measure the potential difference across two terminals of conductor. And pay attention, it should be connected parallel to like the lamp, or even as we're going to see now. The electromotive force. Electromotive force is just what? To measure the potential difference across the two terminals of a battery. When the circuit is opened, it is also measured by voltmeter. So voltmeter can measure the potential difference across two terminals of a conductor or the electromotive force of a battery. Okay, electric resistance. Electric resistance means someone is in front of you or is opposite to you. So it is the opposition that the electric current faces during its passing through a conductor, which means the obstruction to the flow of the current in the electric circuit. Here I have two kinds of electric resistance. The fixed resistance, and this is its symbol, a zigzag line, or the variable resistance, and it has like what? An arrow over it. This represents the rheostat. Okay, this is the rheostat, the variable resistance, and study this part well and know how it works. As you can see here, I have the slider which can change the what? The length of the resistance. This is used to what? So a very important question can come here, the use of the rheostat. It is used to change the value of the resistance, so to control the electric current intensity flowing to the circuit and the potential difference in the different parts of the circuit. Pay attention. When I increase the resistance length, what happens to the current intensity? The current intensity decreases. So you have to know that as the length of the conductor increases, the resistance increases, while as the resistance increases, the current intensity decreases. Now with Ohm and Ohm's law, please study this part well, and you have to know that this is the shape of the circuit that verifies Ohm's law. You can have a question saying that verify Ohm's law. You have to write the whole activity with the steps, observation, and conclusion. Just Ohm here, this German physicist, he discovered the quantitative properties of electric current. And you can say that here he used what? A fixed resistance with a voltmeter parallel to it, pay attention, and a rheostat, which is a variable resistance, and the other components of the circuit. He used this activity to guess about this law, which is saying that what the electric current intensity passing through the constant fixed resistance is directly proportional to the potential difference when temperature is constant. So the current intensity is directly proportional to the potential difference. Pay attention here. Every time he used or he changed the rheostat, he got the reading and put in a table. As you can see, if we just divided the potential difference over the current intensity, always it gives the same value, which illustrates that this value is the constant resistance. We can for sure calculate the resistance and potential difference and current intensity from this triangle. Here, the current intensity equals to potential difference over resistance and so on. Now, 1 ohm is the measuring unit of resistance, equals 1 volt over 1 ampere. What happens when? In the following cases, pay attention. Burning of the fixed resistance in electric circuit concerning the reading of an ammeter connected to the circuit in series and that of voltmeter connected to the battery in parallel. For sure, if I'm going to burn the fixed resistance is a part of the circuit. So the circuit now is opened. Therefore, the ammeter reading will be 0, while the voltmeter reading will be the same. Why? Because it's still connected to the battery, so it is reading the electromotive force of the battery. Here, increasing the potential difference between two terms of conductor to double its value at constant temperature concerning the electric current intensity. The electric current intensity will increase to double also because there is a direct relation between the current intensity and the potential difference. Increasing the value of electric resistance to double its value at constant temperature concerning the electric current intensity. As we all know, I equals V over R, so there is an inverse relation between the current intensity and the resistance. Therefore, the electric current intensity will decrease to half. From the previous explanation, we can conclude the following relations. The potential difference is directly proportional to current intensity at constant temperature. By increasing current intensity, the potential difference will increase and vice versa. Here, as you can see, as current intensity increases, potential difference increases, while the current intensity is inversely proportional to the resistance. So by increasing the resistance, the current intensity decreases. Pay attention to the definitions. I have the coulomb and the ampere. I have two definitions for the ampere according to the first law and the law in Ohm's law. So let's see here the coulomb. It is the quantity of a charge transferred by constant current intensity of 1 ampere in the time of 1 second. Coulomb is a unit. So let's agree on something. If I have to define a unit, so you have to start by the physical property that it measures. Coulomb, it is the quantity of a charge. Okay, so transferred by constant current intensity, 1 ampere in 1 second. While the ampere, ampere equals, what is it? Coulomb over time, over second. So ampere, again, we have to start with, the physical property that it measures. It is the electric current intensity passing through the circuit when 1 coulomb passes through a cross-section in 1 second. And also the volt and the electromotive force. Don't forget, electromotive force is the electric potential difference between the two poles of the battery when the electric circuit is open. Why the electric circuit should be open? Just to measure the potential difference across the two terminals of a battery correctly, so as not part of the electrons flow in the circuit, so you're not going to get the correct reading. Here I have the electric resistance of a conductor. This is the definition for electric resistance of a conductor according to Ohm's law, ratio between potential difference across two terminals of conductor and current intensity. And here another definition for ampere and volt and the ohm. Let's go. So we're going to answer 2 or 3 questions from these, and you have to practice on the others. Mention the physical quantity which is measured by each of the following units. Okay, let's see that. I have the first one, joule over volt multiply second. Okay, how can I deal with that? Joule is the measuring unit of work, and volt is the measuring unit of potential difference. right? Is that true? Yes. And second is time. I can take work over volt and change it into quantity of a charge over time. This relation reminds with you the current intensity. Okay, so let's see the first one. The second one, volt multiplies second divided by ohm. Okay, here also volt multiplies second divided by ohm. Okay, what is it? Volt divided ohm. This reminds you with, yeah, the ampere. Ampere multiplies second gives you what? The coulomb. Coulomb is the measuring unit of, yeah, the quantity of charge. Okay, so this is the second. Third, I have to go to the fifth one. Volt multiplied by second divided by coulomb. Pay attention to this. You may be confused in that. Volt multiplied by second divided by coulomb. Okay, let's see the relationships here. Volt by second, do I have this relation? No. Do I have volt divided by coulomb? Let's revise that. I have V equals W over, yeah, Q. So if I have volt over coulomb, do I have that? No. So it doesn't work because the work done is volt multiply the quantity of a charge. Let's see this one, second over coulomb. How does this remind you of something? Yep. So if I have I equals, yeah, Q over T equals coulomb over second. I know that I has 1 under it, right? This is a mathematical relation. If I'm going to make it 1 over I, it will be what? T over Q. Therefore, 1 over I equals second, or the 1 over ampere equals second over coulomb. So I can remove this one and say it is volt over ampere. Volt over ampere, this is the, yeah, ohm. And this is a measuring unit of resistance. I hope it's clear now. Let's go. And we're going to start in Unit 2, Lesson 2, Electric Current and Cells. Are you ready? It's very easy. Let's go. Sources of electric current. I have electrochemical cells or the electric generators or dynamos. Electrochemical cells, from its name, it can convert the chemical energy into, yes, electric energy. While the electric generators or dynamos, they can convert the mechanical or kinetic energy into electric energy. Examples for electrochemical cells like dry cells or batteries, while example for the electric generator like the dynamo or electric generator. These are the pictures, and this is the dynamo. Okay, types of electric current. Sorry. So direct electric current or alternating electric current. Direct electric current, its source is the electrochemical cells, while the alternating electric current comes from the electric generators. Let's define the direct electric current. It is an electric current which has constant intensity and flows in one direction in the electric circuit, while the alternating electric current, it is an electric current which has a variable intensity and flows in two opposite directions in the electric circuit. We have to know the difference between their sources, as we just mentioned. Direct electric current, its source is electrochemical cells, while alternating electric current comes from electric generators. The intensity here, as we mentioned, it is with constant intensity and direction. Here it is with variable intensity and direction. And the graphical representation for both of them, as time passes, it doesn't change. It is a straight line parallel to the time axis, while here as time passes, sometimes it increases or decreases. That's why it's variable. Also, we have to talk about transference. The direct electric current it can be transferred for short distances only, while the alternating electric current, it can be transferred for short and long distances. That change to another type. The direct electric current cannot be changed into alternating electric current, while the alternating electric current can be changed into direct electric current. That's why alternating electric current is preferred than the direct electric current, because of the transference and change to another type. For the uses, here it is used to operate some electric appliances and, very important, electroplating. While in alternating electric current, it is used to light up the streets, houses, and to operate electric appliances. Methods of connecting the cells in an electric circuit. How can we connect the electrochemical cells to form a battery? It may be in a series connection or a parallel connection. In series connection, as you can see, the negative pole of one cell is connected to the positive pole of the next one, and the negative pole of the second will be connected to the positive pole of the third, as you can see here. And it is symbolized by this. Please pay attention. The positive pole is longer than the negative one. Pay attention. Here, I can draw it like this. Here, I have three cells, positive, negative. Here, no connection. This is one cell. It will be connected to another positive and negative. You have to write here, this is positive, negative, this is positive, negative, and again with another one, positive and negative. For sure, I have two poles for this battery. This is the negative end, so this is the negative pole, and this is the positive end, so this is the positive pole. And the parallel connection, as you can see here, it will be like this. All of them are connected in parallel, where the positive poles are connected in one side and the negative poles are connected in another side. How can we calculate the electromotive force of the battery where cells are connected in series? The electromotive force of a battery is N multiplied E1. So it is a way to increase the electromotive force by connecting the dry cells in series. N represents the number of dry cells, as if I'm going to say here, I have 3 electrochemical cells. So 3 multiply the electromotive force of one of them. While the parallel connection, the E of a battery is the reading of one of them only. Okay, with some practicing, I know also that you are ready for that. You can do it. Choose the correct answer. The watt is the measuring unit of the electric charge. Electric charge means the quantity of a charge. So this is the column. All of the following are used to measure the electric current intensity except. Okay, so I have to get the odd one here. Ampere is the measuring unit of electric current intensity. Coulomb over second, yes, also it is because of quantity of charge over time. Joule by ohm over coulomb. Let's see that. Joule is the work, okay, multiplied by resistance over the quantity of a charge. W over Q means what? V. It is V by R, while here, so as you can see, will be, yes, the joule by ohm over coulomb. Why? Because we all know that I equals, V over R, while here it is V multiply R. So this is not the correct one. Okay, let's go. Which one of the following figures represents a part of an electric circuit that contains an ammeter and voltmeter connected in the right way? Ammeter connected in series, while voltmeter in parallel. Let's apply these concepts. For sure, this is, this answer. If the quantity of a charge which passes in an electric wire is doubled and the time of its passing decreases to half, the current intensity will, okay, let's now write this equation. The quantity is doubled, so 2Q over half T, 0.5 T. If we're going to simplify, 2 divided 0.5 will give us 4 I. So the current intensity will increase by 4 times. In an electric resistance of 20 ohms, if the current intensity passing through it is doubled, its value becomes what ohms? This is one of the confusing questions, as we're going to see in another questions also. Please pay attention. When we say I have a resistance like this, طبعا for sure, this is a definite length. So when we increase the current intensity, it will not affect the resistivity of this resistance. What is the meaning of resistivity? The amount of this resistance or the value of this resistance. Okay, so pay attention, the value remains constant. If I didn't tell you that the resistance, I changed it by my hands, or I increased or decreased the resistance by increasing its length or decreasing it, so don't conclude that the resistance will change. Again, here, this is a definite length for a resistance. Okay. Now, in the electric circuit, the sliding rheostat is used to, for sure, change the resistance value. You may say to control the current intensity potential difference. Yes, by changing the resistance value, meaning that increasing the length or decreasing the length of the resistance value. Therefore, it will control the current intensity and potential difference. According to Ohm's law, at constant temperature, if the potential difference between terminals of a conductor is doubled, so the resistance of this conductor is, think about it. Again, the same question, remain constant. The value of the resistance of an electric conductor in an electric circuit, is it changed on changing what? How can I change the value of the resistance? I just told you, if I said that I'm going to elongate or increase its length or decrease it. So this is by the change of dimensions of the conductor. Dimensions means its length here. As the length of the wire of rheostat increases, length of rheostat increases, so increasing the resistance, therefore decreasing both of the current intensity and potential difference. The current intensity will, yes, decrease as the resistance increased. In the electric circuit in front of you, when the slider of the rheostat moves from point A to point B, the intensity of the light in the electric lamp, okay, let's check this. Here, also, this is one of the confusing questions. The electric resistance, AB, okay, so the slider is here. When the current or the electrons will move, the electricity will move, it will move and pass through all of this resistance. But what if I change the resistance and the rheostat and became here? So the electrons will move without passing through this resistance. Therefore, I decrease the resistance. Decreasing the resistance means increasing the current intensity, so the illumination of the lamp will increase. In the opposite figure, if the slider of the rheostat moves from A to B, then the voltmeter reading, again, let's see and determine what will happen to the resistance. Here, the slider is at A, so the electricity will not face any resistance if it is at A. But what if I changed it to be at B? So the electricity will face all of this resistance. So I increase the resistance. Increasing the resistance means to decrease the current intensity and potential difference. Therefore, the voltmeter reading will decrease. In which of the following figures the reading of the voltmeter is 3 volt, knowing that the electromotive force of each electric circuit is 1.5 volt. Let's calculate with each other. Here it is 1.5 volt because this is parallel, plus 1.5 plus 1.5, this is 4.5. Here, this is parallel, so I will take the reading of 1.5, and this is another one, 1.5. Here, all of them in series, so 1.5 multiplied by 4, this will be 6 volt. While here, again, yes, 1.5 plus 1.5. Okay. Is it the same as here? Did you notice the trick here? Actually, this is a wrong connection. Let me remove it and you will see it again. Let me remove this. Just wait. Yep. So as you can see here, okay, pay attention to that. As you can see here, the negative is connected to the negative. Therefore, this is a wrong connection. Okay. So the correct one is, this circuit. Problems. Calculate the electric current intensity that flows through a cross-section of a wire if a charge of 5,400 coulomb passes through in 5 hours. Therefore, here, please pay attention. I have what? Let me use the pen. Okay. I have to get the given information first. I have the quantity of charge and the time, but I have a problem with the time. Time is in hours. I have to change it into seconds. So it is 5 multiplied by 60 by 60. Okay. Therefore, if you're going to calculate it, it will be I equals 5,400 divided 5 multiplied 60 by 60. Use your calculator. Yes, it will be 0.3 ampere. Now, if the work done to transfer an electric charge of 200 coulomb between 2 points is 22,000 joule, calculate the potential difference. What are the given information again? Let me, use another color. Here I have the quantity of a charge. I have the, work done. So V equals what? Work done over Q. It is equal to what? 22,000 over 200. Cancel 2 zeros with each other. 220 over 2 will be what? 110 volt. Calculate the potential difference between two ends of a vacuum cleaner whose resistance is 22 ohm and the current intensity passing through it is 10 ampere. Okay, what are the given information? Resistance and current intensity. V equals RI equals 10 multiplied 22 equals 220 volt. Okay, let's remove this. Now, calculate the amount of work, so I need the work, for a charge of 40 coulombs, this is Q, to pass through a section of a conductor whose resistance is 10 ohm. Current intensity is, 2 ampere. First of all, I have ampere and resistance, and I need work. Work is what? Work done equals V multiply Q. I have the Q, but I don't have the V, the potential difference. So I have to, calculate the potential difference from Ohm's law, which is V equals, V equals what? R I equals 20 volt. Now let's, substitute here. It is 20 multiply 40 equals, so the work done equals what? 800 joules. Don't forget the units. Let's clear that. Now, in the opposite figure, which is represented by drawing, if the reading of the ammeter when the key is closed is 1 ampere and the electromotive force of the electric cell is 6 volt, calculate each of the following. The potential difference between the two terminals of a resistance 5 ohm. Please pay attention. When the circuit is closed, some of the electrons will move, okay? Therefore, the potential difference will differ. I have 5 ohm as a resistance, and the, how many ampere? 1 ampere. So the potential difference equals what? Ri equals 5 multiply 1 equals 5 volt. What is the reading of the voltmeter when the key is open? When the key is open, this means that no electrons pass or flow in the circuit. So I'm measuring the electromotive force of the battery, which will be equal to 6 volt. Okay, with the next one. Okay. In the opposite figure, calculate the value of E. This is E. That makes the ammeter reading is 2 ampere. I have the resistance 3 ohm and ampere 2 amperes. V equals Ri equals 2 multiply 3, okay, 2 for the current intensity, and R is 3 equals 6 volt. Here is a part of this battery. Therefore, E equals 6 minus 2. Why 2? Because these two electric cells are connected in parallel. So I'm going to take the reading of one of them. It will be equal to 4 volt. Okay, this is 3 multiply 2 gives 6. 6 minus 2 equals the 4 volt. Now with this question, if you have 4 dry cells, the electromotive force of each of the first and the second is 1.5 volt, the third is 2 volt, and the fourth is 3 volt. Explain by drawing how can you connect them to get 8 volt. 8 volt, okay. 1.5 plus 1.5, 3. 3 plus 2, 5. 5 plus 3, 8. So all of them are connected in a series, like this. Okay. But how can we get 6.5 volt? 6.5 volt, this means that I have to connect both of the 1.5 volts in parallel and the rest in a series with this parallel one. Like what? Here, let's see it. I have positive, negative, another positive, negative. Okay, here, positive, here, positive, and negative, negative. And it will be connected like this. Don't forget to write the numbers because this differs for sure. I have 3 volt, 2 volt, and here 1.5 volt and 1.5 volt. Let's check this. 3 plus 2, 5. 5 plus 1.5, yes, 6.5 volt. Okay, let's go. Draw the method of connection of 3 electric cells. The electromotive force of cell number 1 and 2 is 1.5 volt for each one. And the electromotive force of the third cell is 3 volt to produce a battery which is equal to 4.5 volt. Okay, 1.5 plus 1.5, 3. 3 plus 3 equals, what is it? Yeah, 3 plus 3 gives 6 volt. Is this the true connection? No. So I have to put 1.5 volt, both of them, 1 and 2, in parallel. And they will be in parallel with the 3 volt, like this. Let's see that. Positive, negative will be connected with positive and negative, and another one positive and negative, and it will be like this. This is the first one. Here is 3 volt, and each one of them is 1.5 volt. Now, 3 plus 1.5 is 4.5. 3 volt, all of them. All of them 3 volt. How that? Pay attention to this. Okay, both of 1.5 volts can be connected in series to get what? Both of them, 3. So this is 1.5 volt, and this is 1.5 volt. Okay. What else? And let's see that. This is a trick here. Positive, negative. Okay, the 3 volt. Let's check this. Here I have 3 volt, one cell, parallel to another 2 electric cells in series. 3 up and 3 down. I'll take the reading of one of them, which is 3 volt. Okay? So this is the way to draw this part. Choose the odd word from the following: ampere, volt, ohmmeter, ohm. For sure it is ohmmeter because all of the others are units for measuring the physical properties of the electric current. Ammeter, voltmeter, ampere, ohmmeter. Ampere is the odd one because this is a unit and the others are apparatus. Coulomb over second, ampere, joule over coulomb, volt over ohm. Coulomb over second is ampere. So ampere and ampere, I have to search for something else which doesn't produce the ampere. Joule over coulomb or volt over ohm. Joule over coulomb, let's see it. Joule over coulomb is work over quantity of charge. This is the measuring unit for potential difference. So this is the one I need. Okay, let's go. Don't go anywhere. We're going to start in Unit 3 revision, which is the main principles of heredity. This is very interesting. Let's start. What are genetics, or what is genetics? Genetics, it is a science that researches the transmission of the hereditary traits from one generation to another by studying the similarities and differences between the parents and the offspring. Have you ever asked yourself, why do you look like both of your parents? This is because of some factors that will be transmitted from your parents to you. And here is heredity. It is the passing of genetic traits from parent to offspring. Hereditary traits. So we have to introduce first, what is the meaning of hereditary traits? these are the traits that are transmitted from one generation to another. Like what? Like the skin color, the eye color, the height, also the blood groups, and so on. While if we're going to talk about the acquired traits are those traits that cannot be transmitted from one generation to another. It is accepted from the environment. Like what? Like, yeah, the playing football or playing piano or swimming or even talking in many languages like linguistics. And also here, to know how to walk or to practice how to walk. I have to introduce first also, before we proceed with Mendel's first and second law, hermaphrodite flowers. What is the meaning of hermaphrodite flower? It is a flower that carries male and female organs together in the same flower. From which here we're going to say that I have something that is called self-pollination. What is the meaning of pollination? Pollination, it is a transfer of pollen grains to the stigma to fertilize it. If here I have the pollen grains will be transferred from the anther of the flower to the stigma of the same flower or the stigma of another flower on the same plant, so this is called self-pollination. While in mixed pollination or cross-pollination, as you can see here, it is a process of transferring of pollen grains from the anthers of flower to the stigmas of another flower in another plant, but of the same kind. What will transfer it? Actually, this can happen by the wind or some insects like butterflies or bees. Mendel was the founder of heredity. He's the father of heredity because based on his studies, all scientific information and genetics nowadays are known because of him. Okay, so why pea plants? Why did he choose pea plants to conduct his experiments? Actually, have some reasons. Actually, this is because of that it is easy to be planted and it grows fast and its life cycle is short. Its flowers are hermaphrodites, so it can be self-pollinated. Also, it can be easily artificially pollinated by human intervention, and it produces large number of plants in a generation, and also it has several pairs of easily recognized contrasting traits. Actually, he studied what? Yeah, 7 contrasting traits of pea plants, like the flower color, which may be red or white, the flower position, end or side, the seed color, which may be yellow or green, seed shape, smooth or wrinkled, seed stem height, which may be tall or short, the pod or fruit color, which may be green or yellow, and finally the pod shape, which may be swollen or sinuous. Mendel's experiment in heredity. Please be careful and be sure to study this part and know the steps of his experiment. Just to summarize his experiment, he let the plants which produce pure yellow seeds and the plants to produce green seeds to fertilize or to self-pollinate many generations to ensure their purity. Then he got what? The offsprings. The seeds here were all yellow and the seeds here were all green. Then he planted those seeds. Then what did he get? Yes, for sure. If he's going to cross-pollinate them, okay, actually before, after like seeding them, okay, or putting them in the soil to form plants, he removed the stamens of one of them. Why? When I remove the stamens, for sure, to ensure that no self-pollination will happen. Then he, crossed or took some pollen grains from the other plant to this plant, like here, just to make cross-pollination. For his astonishment, he found that in the first generation, all of the generation were yellow. Then after second generation, he let this generation to self-pollinate. He found that some of the second generation were yellow and some others are green. From here, he deduced or concluded the principle of complete dominance. What is the meaning of dominant or recessive? From his experiments, he concluded that some traits or some genes are dominant or dominates over the other genes. For this example, the yellow color seeds, okay, dominates over the green color seeds. That's why when they are crossed with each other, The yellow seeds are the strong one, the dominant one, that will mask the presence of the green seeds. That's why in the first generation, all of them were 100% yellow. But here, they are not pure yet. They are not pure anymore. Now, they will make in the second generation 75% yellow and 25% green. Now, let's introduce the principle of complete dominance. It is the appearance of the dominant hereditary trait in the individuals of all the first generation. When two individuals are crossed, one of them is carrying pure trait, contrasting the trait carried by the other individual. What is the meaning of that? So, appearance of dominant hereditary trait, this is the dominant hereditary trait, the yellow one. In the individuals of the first generation, when a pure individual is crossed by another pure individual, which is contrasting it. According to this, you have to know which characteristics or traits are dominant and recessive in the pea plants. The red colored flower is dominant. The flower position, the side is dominant. Here, the seed color, the yellow is dominant. The smooth seed shape is dominant. The tall stem height is dominant. The green pod color is dominant, while the swollen pod shape is dominant, and the others are recessive for sure. Don't be confused between the color of the seed and the color of the pod. They are the opposite. Here, the dominant one is the yellow seeds. Law of segregation of factors, Mendel's first law. Okay, so it is stated that when two pure individuals of any one pair of hereditary traits are different from each other, only the dominant trait appears in the first generation, while the two traits appear in the second generation at a ratio 3 dominant to 1 recessive. Let's apply this concept here. What is the meaning of dominant gene? Okay, dominant gene, here it is the gene whose trait appears when it exists with a similar dominant gene or with a recessive gene for the same trait. While the dominant trait, it is the what? It is the trait that appears when aggregation of two similar factors, two genes of the dominant trait. Therefore, please pay attention. There is a difference between dominant gene and dominant trait. Dominant gene is a factor, just one factor. If it is found with another dominant factor, so the dominant trait will appear, and this dominant trait is pure. While if the dominant trait, okay, is formed between one dominant factor and one recessive factor, one strong and one is weak, so also the dominant trait will appear, but now it is impure or hybrid. What is the meaning of that? Let's apply this concept. Again, if I have tall stem, okay, with short stem, tall crossed with short. This is pure tall, and this is pure short. In the first generation, we all know that all of them will be tall, but it is hybrid. What is the meaning of hybrid? Yani it is made of one factor you got from the father, one factor you got from the mother, so it is T capital with T small. So if the two factors here are different, they are heterozygous. T capital with T small. But what will appear in front of your eyes? You will see it as tall stem. It's genotype. What is the meaning of genotype? The genetic makeup, or how the genes look like. Are they the same, homozygous, or heterozygous? Actually, this is heterozygous. Sorry, this is heterozygous. Okay. What if I have two factors which are the same, T capital, T capital? These two factors are the same, so they are homozygous genes. How are you going to see them? These are the genotype. So when I say genotype, you have to think about the letters or the genes or the factors. How can you see them? Tall. Tall is the phenotype. Okay, so if I have T small, it is the short one. So T small is the genotype. They are homozygous also, while short stem is the phenotype. How can you see them? Okay, the physical property that you can describe. Okay, also here I have the recessive gene and the recessive trait, and the pure individual. It is the individual that carries a small pair, a similar pair of genes, either dominant trait or recessive trait. So the dominant trait pure or the recessive trait appear on the individual. Hybrid individual, it is the individual that carries a different pair of genes. Like here, I have T capital or T small, while hybrid is T capital with T small. Okay, an important note, the genetic structure of pure dominant individual is symbolized by 2 capital letters, while the genetic structure of the recessive individual is symbolized by 2 small letters. And the genetic structure of hybrid individual, can you see? Hybrid, half and half, is symbolized by 2 letters. One is capital and the other is small. Please pay attention. If I'm going to talk about the flower color, for example, which one is the dominant? Yes, the red. Red is dominant and white is the recessive. What is the first letter from the dominant trait? Is R. So if I'm going to talk about the dominant gene, it will be symbolized by a capital letter from the first letter of its name. So it is R capital. Dominant gene. White, because it's recessive, it will take a small letter or lowercase of the same letter of the dominant trait. So it will be R small. But let's apply this also. If I'm talking about tall and short, which one is dominant? The tall. So the dominant gene will be T capital. The recessive gene will be the short one, T small. Don't say it's S small. No, again, the recessive gene is symbolized by a small letter from the first letter of the dominant trait. Okay. Now, the Danish scientist Johansen used the terms gene instead of the hereditary factors. Hereditary factors just known by Mendel. And also he introduced genotype and phenotype. Again, genotype, the gene structure, like the 2 letters that makes up the genes, while the phenotype for the hereditary trait that appears on the living organism. How can I describe them? Exercise 1. Explain on the basis of genetic principles the result of mating between 2 pea plants. One of them has pure yellow seeds and the other pure green seeds. Mention the ratio between them. Please pay attention. Here we're going to make it with each other. I have parent or parental generation. What is it? Pure yellow and pure green. Which one is dominant? The pure yellow. So it is Y capital, and put them with each other. This is one of the parents, crossed by Y small. Okay, first thing to do is to segregate them to make gametes. Just to remind you, what are gametes? They are haploid cells produced by the reproductive cells. So after meiosis, I have here diploid cells. It will form 2 different cells, 2 gametes. Each one carries what? A factor. So these are the probabilities of the what? The gametes formed by this parent. And these are the other probabilities formed by the other parent, Y small and Y small. So again, gametes, pay attention. Here, parents are diploid, gametes are haploid. If I have here 2 letters, so the gamete will be 1 letter only. First generation. Let's do it. 1, 2, 1, 2. 1 with 1, Y capital, Y small. 1 with 2, Y capital, Y small. 2 with 1, Y capital, Y small. 2 with 2, Y capital, Y small. If you're going to describe all of the first generation, you will say Y capital, all of them are hybrid. Hybrid what? Yellow seeds. 100%. Now, I'm going to take 2 of these 2 offsprings, Y capital, Y small, crossed by Y capital, Y small. Let's do it again. These are the parents. Put them This is one parent, this is the other one. You have here to describe them. This is pure yellow, and this is pure green. This is, both of them are hybrid yellow. Okay, the first step, to form gametes. Gametes are haploid. So one of them will take Y capital and the other will take Y small. Here, the probability to take Y capital and another probability to take Y small. The second generation, 1, 2, 1, 2. 1 with 1, Y capital, Y capital. 1 with 2, Y capital, Y small. 2 with 1, you will say Y small, Y capital. No, it cannot be written like that. You have to write the capital before the small in the same trait. Y capital, Y small. Then Y small, Y small. If we're going to like analyze each one of them, this is pure yellow. These two are hybrid yellow. This one is pure green. But as a ratio or percentage, 75% yellow. You can see them, all of them yellow. And here 25% green. Okay, let's go. Guidelines to solve problems. If mating takes place between two individuals and this mating produces 100% hybrid dominant trait, this means that one of them carries pure dominant and the other carries what? Recessive trait, like that. I have T capital with T small. All of the all of the generation will be hybrid, but dominant trait will appear only. Guidelines to solve problem here, the second one, if mating takes place between two individuals and this mating produces 50% hybrid and 50% recessive, so you have to guess that one of the parents is hybrid dominant and the other is recessive trait. Like pea plant of red flower, it is hybrid, R capital, R small, with R small, R small. Please check that. The gametes here, one of them is R capital and the other is R small, and here I have R small, R small. So 1 with 1, R capital, R small, 1 with 2, R capital, R small, then 2 with 1 and 2 with 2, R small, 50% hybrid red, 50% white flowers. The last one, if mating takes place between two individuals and this mating produces 75% dominant, 25% recessive, this means that both parents are hybrid dominant, like the second generation, the second video generation in Mendel experiment. So it is G capital G small by G capital G small. And you're going to get 75% and 25%. Law of independent assortment, this is the second law of Mendel, or Mendel's second law. It's called law of independent assortment of hereditary factors, Mendel's second law. In the first law, he just what? He was just following one trait at a time. While here, we are following two traits at a time. And by the way, the first law is called law of independent assortment of factors. Here it is called, law of independent assortment of hereditary factors, the second one. The first one, it is the law of segregation of factors, okay? We just mentioned before. Law of independent assortment of hereditary factors, Mendel's second law, when two pure individuals bearing two pairs or more of alternative contrasting traits are crossed, the trait of each pair is inherited independently of the other and appears in the second generation as the ratio 3 dominant to 1 recessive. Okay, what is the meaning of that? So he was thinking about, do the dominant trait here, if I'm talking about red flower, and the white flowers. The dominant is red, while the recessive is white. And the dominant is tall, and the recessive is short stem. So do all the dominant red factors go with the dominant tall stems always? No, they are inherited independently. But let's see that. So if I have a parent which is T capital, R capital, R capital, tall and red with short and white, the confusing part here is to write what? To write the gametes. Please pay attention here. The gametes are very important to be written correctly. So T capital, R capital, R capital. This is one of the parents. And T small, R small, R small. Gametes. So the option for the gametes, I said here I have 4 letters diploid, so I will have 2 letters in each cell because it is haploid cells. The options or the probability to take T capital with R capital, also T capital with R capital. I have only one option. And here also I have only one option, T small, R small, or T small, R small. I don't have any problem here, but we're going to check this from the second generation. So T capital, R capital with T small, R small, it will be T capital, T small, R capital, R small. You have to write both of the 2 letters representing the factors for each trait beside each other, then the 2 letters representing the other trait beside them. So 100% of tall stem and red flowers. Let's see the second part. This is the confusing part. Please pay attention. I'm going to take 2 of these 2 offsprings, T capital, T small, R capital, R small, T capital, T small, R capital, R small. These are the parents. Crossing will happen between them. Gametes. What are the probabilities of having different gametes? T capital may be found with R capital 1 time. So this is one of the gametes formed. And also T capital will be with R small another time. So this is another kind of gamete. T small will take R capital 1 time, and T small will take R small another time. Also here for the second parent. Let's do it again. Okay, with another color. 1 time T with R will be found in one of the gametes, and another gamete will have T capital with R small. Third gamete may be T small with R capital, and the fourth probability will be T small, R small. How can we now show the offsprings in the second generation? We will make the Punnett square, writing all the gametes here. Maybe these are the pollen grains, and these are the eggs or ovules. T capital, R capital with T capital, R capital. So this part is a combination between these 2. But what about this one? It is a combination between this one and the one beside it. But what about this one? It is, this cell or this square, it is in front of this, factor, or, what is it? This one. So we have to combine both of them. Let's see that. So if I have, for example, T small, R capital with T capital, R small, what to write first? I have to write first the T capital, T small, R capital, R small, and so on. What will we get? According to the 2 pairs of contrasting traits, the resultants are as follows. 9 tall stem and 9 tall stems, red flowers, 3 tall stem and white flowers, 3 short stem and red flowers, 1 short stem and white flower, 9 to 3 to 3 to 1. But if I'm going to ask myself about the each trait alone, so we will get 3 to 1 in the second generation. So if I'm going to just mention or describe the tall stems or short stem, the height of the stem only, so I will get 12 plants were tall and 4 plants were short. So by simplification, it's 3 to 1. Plants of red flowers and plants with white flowers, also 12 to 4, by simplification, 3 to 1. Dominant or recessive traits in the human being, be sure to study this part well. So the tongue, the ability to roll the tongue. I'm going to give you some examples, but you have to check them again. So the tongue, the ability to roll the tongue is the dominant one, and the inability to roll the tongue is the recessive one. Curly hair is dominant over the straight hair. And dimples, okay, it is the dominant one, while no dimples is recessive. Wide eyes, dominant, while narrow eyes, the recessive. Black is dominant over the light, and so on. Freckles, no freckles is dominant, and freckles is recessive. we can summarize the previous explanation to the following diagram. Okay, this is how we can describe the what? The genes and chromosomes. We all know chromosomes are made of what? Of DNA, nucleic acid DNA, and protein. The nucleic acid DNA has parts of it, or parts of chromosomes are called the DNA. The DNA, parts of DNA, genes. Okay, also genes have a smaller structural units which are called nucleotides. So nucleic acid DNA consists of small parts called genes, and in turn genes have smaller structural units called nucleotides. These two are Watson and Crick, who made the model for, for what? The double helix of DNA. Battle and Tatum, they received Nobel Prize for their, what they concluded and what they discovered about how the genes can work. Let's summarize them. Genes form enzymes, or they give enzymes. Enzymes are responsible for the occurrence of a chemical reaction. This chemical reaction resulting for the formation of protein. This protein is responsible for the showing of a specific hereditary trait. Now let's go with the last one, and hormones in the human body. What is a hormone? Hormone, it is a chemical substance or a chemical message that controls and organizes most of the vital activities and functions in the bodies of living organisms. The endocrine glands, endocrine or endocrine, both of the pronunciations are correct. Endocrine glands, please pay attention. Endocrine or endocrine glands, these are the glands or the ductless glands. Why are they ductless? Because they don't have ducts like the exocrine glands, like sweat gland, for example. Okay, this is sweat gland, pay attention. As you can see, it is under the skin and it has an opening on the skin. So it can release its secretion directly on the target cell. This is its target cell. While the endocrine glands, they release their secretions in the bloodstream, which will take it to the site of action, which we call it the target cells. They don't have ducts. They don't have ducts like that. So they are called ductless glands. So they are ductless glands that secrete their hormones directly in the blood without passing through ducts. What are target cells? They are the cells that hormones affect, and they are almost located away from endocrine gland that secretes the hormone. So as you can see here, the blood vessel carrying hormones, different hormones, and they are delivering them or transferring them to different target cells. Like here, this is the cell that will receive only this kind of hormone because it suits it. And this also. Hormone disorder. If any problem happens in the endocrine gland, which will cause the increase or decrease in the secretion of hormones, this will lead to a disease symptoms, which is called hormone disorder. Hormone disorder, it is the increase or decrease in the secretion of one of the hormones when the endocrine gland that secretes it doesn't act properly. Most important endocrine glands in the human body, which will be what? The pituitary gland, thyroid gland, 2 adrenal glands, the pancreas gland, and the reproductive glands. As you can see here, the thyroid gland, yes, it is formed of two lobes connected with a small part, and they are found in the front part of the neck at the 2 sides of the trachea. While here, the pituitary gland, it is a small-sized gland in the size of a pea seed, and it is located just below the brain. The 2 adrenal glands, they are found adhering to the top of the 2 kidneys. The pancreas gland, it is between the the stomach and the duodenum or the small intestine. Reproductive glands, I have the 2 ovaries and the 2 testes. Pituitary gland. Okay. Actually, pituitary gland is called the master gland. Why? Because it secretes some hormones which control the activities of other glands. I have 7 examples like TSH, the testosterone, the thyroxine stimulating hormone, and here the growth hormone, and the adrenal gland activating hormone, the mammary glands activating hormone, the sexual gland activating hormone, and here the facilitating hormones for the delivery. Okay, one of the most important hormones that are secreted by pituitary gland, the growth hormone. Growth hormone regulates the speed of growth of most of the muscles, of all the muscles and bones during childhood. If any like disorder happens to it, so the individual will suffer from dwarfism or gigantism. Please pay attention, it is during childhood only. So dwarfism, it is, a disease or a hormone disorder due to the decrease in the secretion of growth hormone during the childhood, which leads to the decrease in the growth or stop the growth. While gigantism, it is the opposite. Thyroid gland, it secretes two hormones, thyroxine hormone and calcitonin hormone. Thyroxine hormone is used to liberate the energy needed from the food for the body, while calcitonin to control the amount of calcium in the blood. Thyroxine hormone also, instead of saying liberates the energy, you can say to for food assimilation. Some diseases resulting from the thyroxine hormone disorder. So I'm going to deal now with the thyroxine hormone only. If I have a decrease in the secretion of thyroxine hormone, the individual or the patient will suffer from simple goiter. And you can describe him by, enlargement of the gland and the neck. While the exophthalmic goiter, it is due to the increase in the secretion of thyroxine hormone. And yes, he's suffering from what? Enlargement of the gland, exophthalmosis. Exophthalmosis is the shape of this eye, how it looks like. Weight loss and tension. Please pay attention. Simple goiter also, one of its reasons due to the lack of iodine element in the supplements or in the food of this individual, because iodine enters in the composition of thyroxine hormone. Two adrenal glands. The adrenal glands secrete adrenal hormone, which stimulates the body for emergency cases like fear, like happiness, and so on. Pancreas gland, which is very important. I have insulin hormone or glucagon hormone. Insulin hormone, please pay attention, it is secreted by the pancreas gland when the blood glucose level is high. Why? To reduce the blood glucose level. So it can do that by transmitting or transferring the glucose from the blood to the cells to use them up, and the excess sugar or the excess glucose sugar will be stored in the liver in the form of glycogen. So insulin hormone converts glucose sugar in the blood into glycogen in the liver to be stored. This is the excess sugar after being used, or after some of the glucose will be used in the cells. Glucagon hormone, it is the opposite of the insulin hormone function. Where glucagon hormone here, yes, it is produced by the pancreas when the blood glucose level is low. This may happen when you are fasting, for example. So the glucagon hormone goes to the liver and stimulates it to change back the glycogen, which is stored in it, to glucose again. Pancreas is a mixed gland, and it's a double function gland. Mixed gland because it can act as an endocrine gland and or ductless and duct gland. Ductless, as we all know, because it secretes insulin and glucagon hormone, which will regulate the blood glucose level. And it can act as a duct gland because it secretes some of the digestive juices in the intestine just to help in the digestion of food. And it is a double gland or double function gland because it has both of insulin hormone and glucagon hormone that contradicts the function of each one contradicts the function of the other. Features of disorder in the secretion of insulin hormone. So if you have any problem in the secretion of insulin hormone, you will guess that the blood glucose level will increase. This will lead to diabetes disease. And this is the tool that we can use to just check the level of glucose in blood at homes. Okay, what about the symptoms? Yeah, multiple urination and so on. Reproductive glands, 2 testis glands and 2 ovaries glands. The 2 testis glands produce testosterone, which it is responsible for the appearance of the male secondary sex characters, while the 2 ovaries they produce 2 hormones, which are estrogen and progesterone. Estrogen is responsible for the appearance of the female secondary sex characters, while progesterone is for the appearance of, or not appearance here, for like what? To promote the growth of endometrium, the lining of uterus. What is endometrium and what is uterus? Uterus, it is the place where the baby is formed inside the mother. So the lining of this uterus is, or the lining of this part is called the endometrium. Okay, with some questions, let's go. What is from the dominant traits in the human being? Okay, straight hair, wide eyes, no dimples, or attached earlobe. It is wide eyes. Mendel removed the stamens of plant flowers before the anther becomes mature to prevent what? To prevent, yes, self-pollination. Mendel observed from his experiments on pea plant that the what trait appears in the second generation at a ratio 25% when studying each trait separately. Yes, for sure, the sinuous pod. Pay attention to this question. The what trait appears in the second generation? For sure, when it appears only in the second generation, it is a recessive trait. Which of them is the recessive trait? The sinuous pod. Hereditary factors are transmitted from parents to offspring by, for sure, gametes. According to Mendel's first law, the hereditary factors segregate when gametes are formed. This is why the first law, or Mendel's first law, is called the law of segregation of factors. The recessive trait appears on one of the sons if he inherited what from their parents? How the recessive trait will appear? Only when he receives what? One recessive gene from the father side and another recessive gene from the mother side. So 2 recessive genes. What trait is pure always? Always pure, for sure, the recessive trait. Because if it is not pure, it will not appear, it will not be expressed. The 2 factors of hereditary trait are similar in pure or hybrid or recessive. Actually, it is impure and recessive, so it is A and C. If 2 hybrid individuals crossing with each other, 300 individuals produced due to this crossing. So the number of the hybrid individuals among offspring may be, okay, if I have what? If I have T capital, just, okay, T capital, T small with T capital, T small. So I have T capital, T capital, T capital, T small, T capital, T small, T small, T small. These are the offsprings. If all of the offsprings are 300, how many of them will be with what? Due to this crossing, number of hybrid individuals. How many hybrid individuals? Half of them. Half of the offsprings. So half of the 300 will be what? Okay, 150. On crossing male and female, the genotype B capital B small with B capital B capital, what will you get? Which produced in their offspring to the total number of offspring. Sorry, on crossing male and female, the genotype B capital B small, and both of them are B capital B small. So the ratio of the genotype B capital, okay, again, let's do it. If I have B capital B small cross B capital B small, so I have B capital B capital, B capital B small, B capital B small, B small, B small. How many of them will be B capital or pure dominant? Just quarter of them. If the genetic structure of one of the producing individuals, A small, so the genetic structure of the parents, how can I get A small in the offspring? If both of the parents have, recessive genes. But which one? Can I get this from these 2 parents? No. Here, no, all of them are dominant. Here, yes, I can take this A small with this A small. But You can say that no, because A capital will always come with A small, so I can't come with A small except in C. The genetic structure of wrinkled yellow colored seeds of a pea plant, wrinkled and yellow. Yellow is a dominant, okay? And wrinkled is what? Recessive. So it will be Y capital, S small. What is or are the parts of DNA present on the chromosomes and control the hereditary trait of the individual? For sure, these are genes. All of the following are considered from endocrine gland except the sweat gland. The what hormones liberates the energy needed from the food? For sure, this is the thyroxine hormone. What elements share in the composing with thyroxine hormone? We mentioned it in iodine. The what hormone stimulates the storage of glucose sugar? This is insulin. Choose the odd word. Car, driving, speaking in English language, learning of walking, and skin color. The only hereditary trait is skin color. The others are acquired. Dwarfism, gigantism, diabetes, simple goiter. Think about it. Dwarfism, due to decrease in the growth hormone. This is increase in the growth hormone. This is decrease in insulin hormone. This is decrease in thyroxine hormone. Decrease, and just one of them is increase. So this is the odd one. Estrogen, progesterone, testosterone, adrenaline. Adrenaline is the odd one because the others are sexual glands hormones or reproductive glands hormones. Gigantism disease is a continuous growth in the limbs bones due to the deficiency of growth hormone at the childhood. Actually, this is wrong, due to the increase of growth. The acquired traits are transmitted from one generation to another? For sure not. You're not going to transfer, or it will not be transmitted for your children if you're going to talk in Japanese or something. Thyroid glands secrete a hormone that organizes the growth and development of sexual organs in the human body. Yes, this is for sure wrong. Why? Organizes the growth? No, organizes the growth. This is for sure the pituitary gland. Give reason. There is a strong relation between pancreatic gland and the adrenal gland. Please pay attention to this part. This is one of the deceiving or confusing questions. What is the relation between adrenal gland and pancreatic gland? Adrenal gland, as we said, it helps the body or stimulates the body if you have any emergency case. In any emergency case, like when we say fight and flight, if you're going to fight or even you're going to run, so you need some energy. When you need energy, so the pancreas will just release what? Release glucagon hormone. Why? To change some of the stored glucose sugar in the form of glycogen in the liver to glucose again, which will be used by your muscles to get ready for, yes, your fight or something like this, or even you're going to run. Okay, correct the underlined words. If the result of crossing between two individuals is 50% dominant and 50% recessive without thinking, so what about the parents? One of them is hybrid dominant and the other is pure recessive. The ratio of gametes T capital R capital in pea plant whose genetic structure is T capital T small R capital is small is 75%. Pay attention to this. Ratio of gametes. Here is the parent. What are the gametes formed? One of them is T capital R capital. The other is T capital R small. T small, let's write it here, T small R small and T small R capital. What is the ratio of finding T capital R capital in the gametes? Just 1/4 or 25%. Both Muhammad Blue Eyes and his wife Wafa Blue Eyes fight with Samir Blue Eyes and his wife Suad Brown Eyes on child's attributions, whose eye is brown. The judge issued his just judgment to any parents. Okay, if the child is brown, can he come from two recessive traits for parents? Blue eyes and blue eyes? For sure not. So the child is the son of Samir and his wife Suad because the blue eyes is a recessive trait, while the brown eye is dominant, and it can come only from what? A dominant parent. So if this is for sure, yes, Suad. Russia agrees on the idea that says that her black cat can give birth with a white individual when it is crossed by a black male cat. Mariam refuses this idea. Which idea is correct? Give reason. So Rasha believes that if she has a black female cat, and this female cat will be crossed with or mate another black male cat, can they give rise to white cats? You will say that both of them are dominant, black and black. No, they can't. Actually, they can. When both of the two cats are hybrid, like B capital B small with B capital B small, for example. So here, B capital B small with B capital B small. So when these two factors come together, they will show the white color of the cat. Okay, that's it. And just believe in yourself. You are unique, you're smart, you're talented, and you really matter. Thank you and goodbye.